ladies and gentlemen. Today we're going to talk about slope. So what is slope? Well, all slope is it's a comparison between two numbers, y and x. Those are two different variables. And usually it's written as a fraction, right? Change in y divided by the change in x. That's all slope is. Slope looks a little different whether you're on a graph, working with coordinates, or a few different ways. But it's always change in y over change in x. On a graph, you may remember it as rise over run. But rise over run is literally the same thing as change in y over change in x. Here's why. The rise, if I have my line right here, I'm trying to find the slope of the line, all I've got to do is pick 2 points. So let's pick this one and this one. I could pick any 2 points in that line, but I'll just pick those two for now. So I need the rise and the run. Well, the rise is how far I have to go in the up and down direction. Remember, your rise is the change in the up and down or the y direction, so the rise is actually the same thing as the change in y. The run is how far between those 2 points you have in the left and right direction, and that left and right direction is the x direction. So the run is literally the same thing as the change in x. So if I start at this point, call this point 1, that point 2, I've got to go down 2 squares, so that'll be a change in y or a rise of minus 2 or negative 2. Okay, can I see the negative? So let's move this over a little bit. Negative 2. And a change in x in 1, 2, 3, 4, 5, 6. 6. Okay, and so negative 2 is my change in y or my rise. 6 is my change in x or my run, which means that my slope is negative 2 over 6. That's all it is, right? Negative 2 over 6. We can simplify that to, let's see, both the top and the bottom, the numerator and the denominator, can be divided by 2. So that's negative 1/3. There's my slope, negative 1/3, right? So that's why change in y over change in x, or rise over run, whichever you prefer. Now, a lot of people use this formula too. They say, well, is the formula the same as rise over run and change in y over change in x? And the answer is, it is the same, right? y2 minus y1, if we were to write down the coordinates of these 2 points, right, and plug them into this formula, we would get negative 2, right? Because y2 minus y1, subtracting the 2 coordinates here, gives us our change in y. Same thing for x2 minus x1. If we wrote down the coordinates of these 2 points and subtracted them, x2 minus x1, we would get the same number here, 6. The same as our change in x. Let's actually do that. So let's write down the coordinates of these 2 points. So this is 1, 2, 3, 1, 2. So this is negative 3, comma 2. And this is 1, 2, 3, 0. Okay? X coordinate, then y coordinate. So I've got negative 3, 2, and 3, comma 0. And I could do this, the same thing as before, find my change in x, my change in y, using the formula, or using change in y over change in x, and I'm not even going to use the graph. Let me show you how. So let's go down here. Okay, here I've got the coordinates. And now I'm going to try and find the slope 2 different ways. Change in y and change in x. Well, when we say change, we literally mean change. So we look at the 2 y coordinates, 2 and 0. Okay. And what happens between 2 and 0? What changes? Well, we're going down 2. It's decreasing by 2, so our change is negative 2. Change in y, negative 2. Okay. What happens from negative 3 to 3? Well, okay, negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, so we're increasing by 6. Increasing by 6 for our x coordinates. So change in x is plus 6. Okay, negative 2 over 6. Well, that was exactly the same thing I got when I did rise over run, right? And that simplifies to 1/3. 1/3. I could also use the formula, right? I could use the formula. I've got to label my points though. So this is x1, y1, x2, y2. Okay, so y2 is 3, y1 is, let's see, I'm sorry, y2 is 0. Okay, 0. Y1 is 2, so 0 minus 2, over x2 is 3 minus negative 3 is my x1. Okay, so 0 minus 2, that's negative 2. 3 minus negative 3, well, if I'm subtracting a negative, that's the same thing as 3 plus 3. the parentheses there. And so that's 6. And look, negative 2 over 6. Same thing I got for my change in y over change in x, and the same thing I got for my rise over run up here. Okay? So again, this simplifies to negative 1/3. And I'm sorry, this should have been negative 1/3 as well. So all three ways, right, we get the same answer. Now, what's the difference between the three ways? Well, not very much, right? Using rise over run is good when you've got a graph in front of you, when you can easily count the change in y, the change in x, or the rise and the run, easily on a graph. Just looking at the second method, the change in y and the change in x, seeing what changes from one number to the next, is useful if the numbers are pretty small, like 2 and 3, 0. Those are pretty small. I could easily tell that from 2 to 0, I'm decreasing by 2. Okay, negative 2 there. This third method, the formula, a lot of people like to use, but I don't. I only really use it if I'm using very, very large numbers that I can't easily figure out the change in y or change in x, or if I don't have a graph with me. But otherwise, I always try and use one of the other two methods. Like I said, the formula works just because when I subtract two numbers, that's the same thing as finding the change in the two numbers, or the same thing as finding how far two numbers are apart. However, it might happen that you forget that 3 minus negative 3 is really 3 plus 3, which is 6. You might forget that, but you wouldn't forget it if you're simply looking at how far these are apart, right? What the change in x is here. And that's why I don't always like to use the formula, but you can, and it will work. Okay? In the next video, I'll show you how to do the same kind of thing with distance.